Hey everyone, so this video is a continuation with the previous two videos. We are discussing hydrographs and problems on that and some concepts here and there which are important to understand the problems. So here till now we have understood the conversion of flood hydrograph, direct runoff hydrograph and unit hydrograph, and given with the data of any type of hydrograph, how can you find out the other quantity, basically the catchment area or the depth of runoff. Now here one more important concept is there, that how can you convert a unit hydrograph of a given duration to a unit hydrograph of any other duration. So our aim is to find out or to convert unit hydrographs. So within the unit hydrograph also, how can you convert from one unit hydrograph of a particular duration to another unit hydrograph developed for any other duration. Now it is very obvious that the hydrograph which you will get for a 2 hour effective rainfall occurring over an catchment uniformly, so whatever hydrograph you will get for 2 hour will be different obviously from what you get for a 4 hour or 4 hour of duration. When the duration of this effective rainfall is 4 hours, then the hydrograph that you will get, unit hydrograph, will be different. So we have to find out, or we have to generate for a particular catchment different durations of unit hydrograph, so that as and when need I can get the corresponding DRH. My aim is to find out the peak value of flood and the time to peak value. For that I need to know the unit hydrograph, so that time to time I can convert. In the coming series you will also be understanding how at any section, suppose this is a catchment and at this particular stage you have the hydrograph. So how can you get the hydrograph at this particular segment? Or how can you get the hydrographs maybe some 10 kilometers away? So this basically this process of getting hydrographs at any other location given you know the previous location hydrograph, that is called flood routing basically. So here hydrograph is again a very important information that you should have to design your structures, basically hydraulic structures. You need to know the flood value. Flood here I refer to runoff or the peak value of runoff. That is nothing but flood. Now, so to understand or to get the information about such hydrological events like floods, like droughts, maybe to even to analyze droughts you need to understand the uh, rainfall runoff pattern. So in all that case I need the hydrograph of different duration, because you cannot say that every time 2 hour of rainfall will be occurring over a catchment, maybe 3 hours, maybe 2.5 hours. So in that case you have to keep the unit hydrographs, you have to generate the unit hydrographs of different duration. Once you have the unit hydrograph, you can always derive a DRH out of it. And you can always derive a FRH out of it. Now, in this particular segment, we are going to look at only the conversion when we have a hydrograph of D hour and we want to generate a hydrograph which is an integral multiple of this number. So, what I mean to say is there are different ways. For example, just ignore these two graphs and just try to understand here. What I'm trying to say is this conversion can be two ways. For example, you have a 4-hour unit hydrograph and you want to convert a 2-hour unit hydrograph. Okay. And you have a 2-hour unit hydrograph and you want to know the 4-hour unit hydrograph. We are only going to look at this method, not this. Okay. This can be done by S curve, which we are not discussing now as it's not there in our syllabus. It's there in the grade syllabus, so we'll be covering that part later. But now for the semester exams purpose, we are only discussing this method, and this is called method of superposition, in which I can generate a unit hydrograph which is of a duration which is an integral value of the previous duration. That means from d hour I can only generate n d hour, where n is nothing but an integer value. So n is an integer. It cannot be a fraction, whereas you see here it is a fraction. Here it is 1 by 2. Here it is 2. So there are two ways: method of superposition. Superposition, which is, you are already familiar with this method of superposition. We do it in structures also, where we find the deflection at any particular section of the beam due to a given loading. So we use this method of superposition in that deflection also. And the other one is called S-curve. S-curve is a broader aspect where I can generate any duration unit hydrograph from a given unit hydrograph. So I can generate integral value, I can generate for the fraction value, for anything, like from 2 to 6, from 6 to 2, both I can do. But in superposition, I can only do from 2 to 6. That means from a 2-hour unit hydrograph, I can find out the 6-hour, the 12-hour, or means which are the multiples of 2. So that I can do. So here you please make a note that this one is done by method of superposition. So this method we will see now. Method of superposition, what do? We try to use the assumption of unit hydrograph that is called time invariance. Now what does that time invariance say? So we have seen linear response in the previous video, where we were multiplying the ordinates of UH by 3 centimeter, and we were saying that I am getting a 3 centimeter DRH. This is called linear response. Okay. So ordinates of UH I can multiply with 3 centimeter and I will get 3 centimeter DRH. Now there is one thing that is called time invariance. And what is it? Time invariance says that if you got a hydrograph due to 2 centimeters of runoff, if you get a hydrograph, let's say DRH or UH for that matter, so if you get such a hydrograph for 2 centimeter runoff hydrograph in morning, you will get the same hydrograph in the evening due to this particular centimeters of runoff. So it is independent of when it occurs. That is nothing but time invariance. It is independent of when it occurs, which is practically doesn't seem logical, because you see initially catchment is dry. You just assume initially catchment is dry, so you will get certain runoff. That means you will get less runoff. But later, when the catchment when the soil is completely moisturized, then what will happen? You will get more runoff. So how can you get same hydrographs? But we are assuming that independent of, irrespective of when the rainfall occurs, you will get the same hydrograph. Using this, we will derive. Now, imagine that this is a axis on which I am going to plot the hydrograph. Okay. Now, what is this? Basically, I have taken, if you remember, there is a term that we have discussed that is called HYDROGRAPH. HYDROGRAPH. HYETO. HYDROGRAPH. So HYDROGRAPH basically tells you about the intensity of rainfall versus time. And in that also, when you take only effective rainfall, that means when you neglect the losses, that means when you neglect the portion which is below the phi index, that particular portion which is above the phi index is called effective rainfall hydrograph, that is called ERH, effective rainfall hydrograph. That means only that value of rainfall which contributes to runoff. That is what I have plotted here. For example, here I am trying to say that from 0 to 4 hours, here I plot the time, and here I will write what is the intensity of effective rainfall. So I am saying that because I am dealing about unit hydrograph, I know the depth of rainfall should be 1 centimeter. Which rainfall? Effective rainfall. So here, see, again and again, and why I am repeating the previous video also, you please notice unit hydrograph is plotted for 1 centimeters of effective rainfall. Okay, because effective rainfall is the rainfall which will contribute to runoff. Other rainfall will go into the ground, right? Or maybe it will evaporate. So here, let's say for first 4 hours there was 1 centimeter of effective rainfall in the catchment, and due to which I got a hydrograph. Okay. Now I am saying after that, for another 4 hours 1 centimeter of effective rainfall has occurred. After these 4 hours, next 4 hours also same effective rainfall has occurred. So as per the time invariance, I should get the similar hydrograph. But this time hydrograph will start from here, because this hydrograph is after 4 hours, right? So let me draw. It will be something like this, but exactly, please ignore the drawing part. I am trying to say it should be exactly similar. Okay. If I want to know the resultant of these two, simply I will superimpose these two graphs and I will get some higher value. So if this is A and this is B, this is A plus B, or let me call it as C. What is this A and B? A is a DRH due to 1 centimeter. Okay, this is a DRH due to 1 centimeter of effective rainfall, or you can say it is 1 UH. It is a 4-hour UH. Can I not say, because this is due to 1 centimeter, right? So I'll write, let me write please. It is a 4-hour UH. This green one. This yellow one is also a 4-hour UH. So can I not say this is what? This is 8-hour. Will I say UH or DRH? I will say it is a DRH, because this is due to 1 centimeter rainfall. This is due to 1 centimeter. When I add, it will become 2 centimeter. And I know anything other than 1 is not UH. So I will write it as DRH. Here I can write 4-hour 1 centimeter DRH, but I know 1 centimeter DRH means UH. So here the effective rainfall will also add up. So this final curve, the blue curve, is a DRH due to 2 centimeters of effective rainfall which has occurred in a catchment for 8 hours. So what do you observe here? I have converted a 4-hour UH into a 8-hour DRH, and from this I can easily convert DRH to UH. You already know. You just have to divide the ordinates by 2. So from here to here, let me use this. Somewhere like this will be your, this final white curve will be your 8-hour UH. It will be your 8-hour UH. What you have done? From 8-hour DRH, you have divided the ordinates by 2 to get a 8-hour UH. Now I'll simplify the things. For the derivation part, I have showed you what I have done. I have taken a 4-hour UH, then I have delayed it by 4 hours so that total it will become 8 hours. 8 hours of effective rainfall. That means first in 4 hours and another in 4 hours. And then I have delayed it, added them and divided by the ordinate. So what I have done, you can note down the steps basically to avoid any confusion. We will write down the steps. So first step is, so what we are doing, steps to convert unit hydrographs by method of superposition. So first what I have done, so we already have, so already we have a unit hydrograph of d hours and I want to convert it to 2d hour unit hydrograph. Let me say, for example, here I have a 4-hour UH and I want to develop a 8-hour UH. So n will be 2. Please note, I cannot do vice. I cannot do the reverse using this method. I cannot generate a 8-hour, I cannot generate a 4-hour unit hydrograph from a 8-hour unit hydrograph. So now this is something which I already have. So the second thing that I have to do is I have to draw this 4-hour UH and another 4-hour UH which is delayed by 4 hours. That means to develop a 8-hour UH, I have to draw two 4-hour UH but not together. Delayed it. I have to delay it because after first 4 hours, again I am assuming that effective rainfall is continuing. Because 8-hour UH means a rainfall which has continued in a catchment for 8 hours. So either you say a rainfall which has continued in 8 hours or you say a rainfall first continued to first 4 hours and that same rainfall continued to next 4 hours. It's the same thing, right? So here, what will I do after this? First, I will delay it and then I will add both of them. Now, I will add the ordinates of both the hydrograph graph and that will give you ordinates of what? When I add two 4-hour unit hydrograph, I will get one 8-hour DRH. Why? Because this is 1 centimeter, this is 1 centimeter. 1 centimeter is what? The effective rainfall. So whatever you will get will be due to 2 centimeter effective rainfall. And 2 centimeter I cannot write it as UH. It has to be DRH only. Because UH is only for 1 centimeter of effective rainfall. Now, again, let me repeat. The last step is divide the ordinates because your aim is to arrive at UH, not at DRH. So divide the ordinates by 2. Here in this case by 2. In general case I have to divide by x. Suppose here let's say I have taken 3-hour UH and I am finding out 12-hour UH. So I have to divide by 4. With the help of questions it will be more clear. So This 2 is particularly for this case, okay? So please, when you are watching this video, please do not assume that you have to divide it by 2 every time. Here, because I am delaying it only one time, so the total duration is 8, which is multiple of like 4 into 2 is 8. So that's why I have taken 2, okay? So divide the ordinates by 2 and that gives you 8-hour unit hydrograph. So these are the steps that you have to follow. Strictly follow these steps and you will be always like you will never be getting any problem. Now here, to avoid the confusion, let me repeat it one more time. Suppose you have a D-hour unit hydrograph and you want to develop a T-hour unit hydrograph. Suppose you have a D-hour unit hydrograph and from this you want to develop a T-hour unit hydrograph. So what you have to do is you have to delay it. You have to delay this D-hour unit hydrograph. How many times? Whatever is the multiple here. For example, here the multiple is, let's say, 3. So you have to delay it by 3 times, then add it up. When you will add, you will get a DRH due to 3 centimeters of runoff, and then you have to divide by 3 so that you get the T hour of unit hydrograph. So that is what you remember here. Here n can be any integer value, any integral value it can be. Now with the help of problems, I hope it should be clear to you. So let me write a problem. Here in this problem, from a 2-hour unit hydrograph, derive the ordinates derive the ordinates of 6-hour unit hydrograph. Now, how will you do? First of all, you should have a 2-hour unit hydrograph. Only then you can do, right? So let me take a very simple example, okay? Simplest of the simple. Simple of the simplest. So 0, 2, 4, 6. Let's say this is the data. Let me take some more values because it might not. Yes. 0, 2, 4, 6, 8, 10. Okay. Now here let me take the ordinates of 2-hour UH, okay? These are the ordinates of 2-hour UH. Let me write 2-hour UH. Okay. So what are the values? Values are, let's say, 0, 20, 40, 50, 30, 15, one more. One more value, 0. Okay, so it's a DRH due to 1 centimeter. So instead of saying DRH due to 1 centimeter of effective rainfall, I'll say UH. Okay. And this effective rainfall has occurred in a catchment for 2 hours. For that, I have to find out for 6 hours. So my step 1 was, given the data, you delay it. So for first 2 hours, then for next 2 hours, then for next 2 hours. So how many times you will delay? First you will get a hydrograph here, then you will get here, and then you will get here. Something like this if you remember, and then I will add it up. So you have to delay 2 times. Okay. So I am just erasing this. Erasing. Okay. Now here I will write that this is also a 2-hour UH but delayed or lagged by 2 hours. By 2 hours. So what I will do, I will shift the ordinates by 2 hours. So how will I shift like this? That means in the first 2 hours I should not get any value because this unit hydrograph is same but starting after 2 hours. So I hope I have cleared it. I would like to think so. I am just delaying, I am just shifting by 2. Okay, now this is one time shift. Now again I have to find it for 6 hours. Same thing I'll be repeating here. Here actually let me do it in columns so that it will be like easy to understand for you guys. This is one column, then this is one column, then this is also another column, then one more column here. Oh, okay. Then let me write 2-hour unit hydrograph lagged by what? 4 hours means same values but after 4 hours, and the values remain same because irrespective of the time, if the effective rainfall is same, hydrograph will also be same. This is called time invariance. Be it morning, be it evening, summer, monsoon, whatever it is, okay, the hydrograph will not move. The hydrograph will not change. So here I am shifting these ordinates again. That means here I will get the first ordinate at, so you please don't confuse. Okay, please don't confuse. Here I will not get any values and I will get the value from here. So 0, 20, 40, 50, 30, 15 and then 0. Now the next step was to add all these ordinates. When you add all this, what will you get? 0 plus blank. Okay, let me denote it by blank. Okay, blank means you have shifted, so there will be no value here. Now again I'll make another column, and in this column I'm going to write the addition of column this plus this plus this. And what will be the addition? Addition will give you an idea about a DRH due to 3 centimeters of effective rainfall, and it is occurring for 6 hours. So for 6 hours I can write. So simply add these columns. 0, again it will be 20, then 40 plus 20 plus 0, that means 60, then what, 50 plus 40 plus 20. So here it is a bit up and down, but I hope you understand. Here we have left one value and here we have left two values and then shifted the ordinates. So what you will get here, 110, then it will be 80 plus 40, it is 120, then it will be 15 plus 30, 45 plus 50. 45 plus 50 is how much? 95. Then 0 plus 15 plus 30, 45. Then 15. Then 0. So one more thing you see, 2-hour UH was ending here. But you see 6-hour UH will not end here. It is like after 2 more hours it will end. Okay. So this is nothing but, this is what we got is Here what I have got is, it is a DRH. My aim is to find out a 6-hour UH. This is my aim. From DRH to UH, how do I go? I will divide the value of x. I will divide the ordinates by x. What is x? 3 centimeter. So whatever is the runoff, I know only for 1 centimeter of runoff I want to calculate, but this is for 3 centimeters, I will divide by 3. As simple as that. 0, 20 by 3, that means approximately 6.67. 60 by 3, that means 20. 110 by 3, approximately 36.7. 120 by 3, that means 40. 95 by 3, 31.7. Then 15, 5, 0. So if I want to know the peak value, at times question asks you the peak value also. So if you want to know the peak value of a 6-hour UH and a peak value of 2-hour UH, you will see this. So what does it mean? The same rainfall, when it was occurring in 2 hours, it was this much, and when the same rainfall is occurring for 6 hours, this is what you got. That means, see, you try to understand, the volume remains same. But if something is happening in 2 hours and something is happening in 6 hours, so here in this case, you will have a broader base, whereas in this case, you will have a greater height. That is why this Q peak is greater than this Q peak. Here it is 40. So you understand, same rainfall coming in different duration. Volume is same. Here time base will increase and here peak will increase. If these two shaded areas are same, in this case peak will be more, in this case time base will be more. So this is for 2-hour UH, this is for 6-hour UH. So I hope you understood. In this problem we have learned how can we convert from 2-hour to 6-hour, from 3 to 12, from 4 to 24. Like that you can keep on converting by using method of superposition. First you have to shift the ordinates and then you have to find the DRH, and then from DRH to UH you can simply find by dividing the ordinates by x centimeters of runoff. This was our aim in this particular lecture. So I hope you understood. So thank you so much for watching the video. And then if you have any doubt, please don't forget to post your doubt in the comment section.